So this video is meant to explain quadratic equations and the vertex form of quadratic equations that help us to graph them. So in general, a quadratic equation looks like this, where we'll have y equals ax squared plus bx plus c. And a, b, and c are just real numbers. We notice that we have an x squared term, so that's where we're different from our line equations, where we didn't have that x squared. We just had a y and an x. So that's generally what they look like. And what we've learned since has been the vertex formula, or form of a quadratic, rather. And that looks like this. Y equals a x minus h squared plus k, or we can look at it as the y minus k equals a x minus h. These both say the same thing. I've just moved the k from one side to the other. The book, I believe, uses this form, but I'm going to use them interchangeably because they're essentially the same thing. What do we know about this equation? Well, this form tells us a lot about the parabola that we're trying to graph here. And let's write down some of the things it tells us. So it tells us about the vertex. And now, this is the one trick that you need depending on which side you're looking at here. The vertex for both of these, because they're the same equation, is h comma k. Now, if you're looking at the left equation, if you like to have the k on the right and just have the y all by itself on the left, which is what you'll have to do to plug these into your calculator to graph it, is the h is the opposite sign, much like we looked at with circles. So if it has x minus h, the positive h is going to be the x component of the vertex, the x coordinate. And the k has the same sign. So we've got a plus k here, so we get the plus k. If you're looking at the right, they're both opposite. So the negative h, the x minus h there, means that we have a positive h as an x coordinate of the vertex, and the minus k, since it's on the left side, means that we have a positive k as the y component of the vertex. So that's one thing. The next piece there, so we've got the h and the k, the a. The a is another important piece to this puzzle. A does two things. The a determines the width of the parabola. So if, and I'll do the absolute value here because we're going to talk about the sign of a in a second, but if the absolute value of a is less than 1, so basically if we're between 0 and 1 here, we're going to get a wider parabola. And we'll see some examples of this in a second. And if a is bigger than 1, then we're going to get skinnier. The other thing that a does is it determines whether you're going to open up or open down as a parabola. So a determines, I'll say up / down. So if a is less than 0, so if a is negative, we're going to open downwards. And if a is greater than 0, so if a is positive, then we get the nice upward opening parabola. So there is our kind of beginning here. This is what we're going to start with, is our vertex form. And again, you can look at it either way. You can put the k on either side. Just make sure you keep straight for your vertex which side it's on. And we've got that a term, that scaling term, which tells us if it's up or down or wider or skinnier. So now let's take all of this and let's do some examples and learn how to go from our standard right here into our vertex form here or here, whichever one you like to use better. And the way we're going to do that is by completing the square. So now what I'd like to do is look at a few examples, and we'll go through and just see how this all works out. So let's start with this example. Y equals x squared plus 4x plus 5. And what we want to do here is we want to put this into that vertex form, and we're going to do it by completing the square. So I'm going to present two ways of solving this problem, and I'll let you determine which way works best for you. So the first way is to subtract this 5 here, just like we did with completing the square before. So I have y minus 5 equals x squared plus 4x. Now I can kind of forget about the y minus 5 for a second, and I'm actually just going to copy it down because I'm not even going to do anything with it right now. And what I want to do is complete the square on the right side. So I need to take that 4, this 4 right here, divide it by 2 and square it and then add it, just like we've done before. X squared, the 4x stays. Now I divide the 4 by 2, which gives me 2, and then I square it, which gives me 4 again. So I'm going to add 4 over here. But, and I'm going to do this in red so we remember, I've added 4 to the right side, and in algebra, if you want to do something to one side, you have to do it to the other. Otherwise, we're changing our equation, and as I like to say, we're breaking algebra. We're breaking all the rules. So I'm going to add a 4 here, so I'll put a plus in there too. So I'm adding 4 to both sides. That way, I've essentially done nothing to change my equation. I added 4 to both sides. It turns out that's just the same as adding 0, so we haven't changed anything. All right, let's simplify a little bit here. So now on the left, I've got a plus 4 and a minus 5, so I think that gives me a y minus 1 is, and now since I did my complete the square step, there we go. I've just got x plus 2 quantity squared. So what do I know about this? Well, let's come over here. I know the vertex is going to be the opposite of that inner one, so I've got a plus 2 there, so it's going to have to be negative 2. And it's going to be the same as that. Since I have y minus 1, it's actually going to be a positive 1 there. So there's my vertex. My A is 1, which means that I'm going to open up like this. And I haven't made it skinnier or fatter, so since that 1 isn't going to do any scaling there. So that's about all I know there. I could graph this if I wanted to by plotting some points, but we're not going to do that right now. But that's how you go from that quadratic into a nice vertex form of the parabola. I'm going to show you another way to do this, and it entails a little bit more, it's a little different than what we've done, but it just keeps everything on one side, so you can leave y kind of alone here. So what I'm going to do is we'll make another line here. So I'm going to start with the original problem, y equals x squared plus 4x plus 5. And what I'm going to do is I'm just going to throw in some parentheses here. And they're not really going to do anything right now, but in a moment you'll see why I did this. So I'm just going to kind of separate that 5 out of there. All right, I haven't changed anything. I just put in some parentheses. So what I'm going to do is instead of thinking left and right sides of the equation, I'm going to think inside and outside of the parentheses. All right, so I need to complete the square inside the parentheses. So what I'm going to do is y equals x squared plus 4x. Divide by 2 is 2, square is 4, so I'm going to add 4. So since I've added 4 inside the parentheses, I'm going to leave that 5 there, and I'll do this in red. I need to add 4, I need to subtract 4. Since I've added 4 inside the parentheses, I need to subtract 4 outside the parentheses, so that again, my net change is adding 0. And then with one more step, I think we can get to the same thing we did above. So again, the 1 has slid over to the other side, but it's the same equation. We've got a y equals x plus 2 quantity squared plus 1. So my vertex is going to be minus 2 comma 1. My A is still 1. It's going to open upward. That's the same. I get the same equation. So there's 2 different ways to do this, and let's look at another example. So let's look at this problem. Y equals minus 2x squared minus 8x minus 7. And again, we want to get this into the vertex form of the quadratics here so we can learn a little bit about our parabola. So again, I'm going to do this 2 different ways. In the first way, I'm going to add the 7. And remember, both of these ways still do the same thing. It's just however you want to think about it. So y plus 7, I've added the 7, is negative 2x squared minus 8x. Okay. Now what I want to do, since in order to complete the square, I need a lead coefficient of 1. So essentially this right here, I need to be 1. So how can I make that a 1? Well, I can divide by -2. So that means I need to divide everything. Everything gets divided by -2. So now what I get, the left side's going to look a little messy, but it's nothing too scary. And now the right side, I'm going to get x squared. Now, a -8 divided by a -2 should give me a plus 4x. Now I'm ready to complete the square on the right side. So I'm going to do, the left side is going to stay the same. X squared plus 4x. Now again, this is the same as the previous problem, it turns out. So if I have the 4 there, I need to divide it by 2. I get 2. I square it, I get 4. So I'm going to add 4. Now I'm going to go and I need to make sure that I add it to the other side as well. Okay, so now I think I'll leave this here for the moment. Y plus 7 over 2. I'm ready to complete the square on this side, so y plus 2 squared. Now, in order to get it into that right form that I want, what I've got to do is I have to get the y out of this this fraction here. So what I'm going to do is I'm going to kind of go backwards from what I did before. Oh, and I forgot my minus. That's important. Don't forget that. There's a -2 there. So what I'm going to want to do is multiply everything by a -2. So if I multiply 4 by -2, I get a -8. Now this gets multiplied by -2. They're going to end up canceling, so y plus 7. And I'm going to get a -2 over here. X plus 2 quantity squared. So I've multiplied everything by -2. Let's simplify on the left side. Y minus 1 is -2. X plus 2 squared. And there we have it. We are in our vertex form. So the vertex is going to be, let's see, it looks like it's going to be a -2, 1. And my A term is -2, so I know that I'm opening downwards, and I know it's going to be a little skinnier. Because that term is no longer 1, it's now, the absolute value of it is now bigger than 1, so it's going to make it a little skinnier. So let's go over on the right side here, and let's try this keeping everything on the right side again. And let's see just how different it looks. So we're going to start with the y equals -2, x squared minus 8x minus 7. That's an 8, okay? So if I want to keep everything on the right side, again, I'm just going to think of those first two terms and I'm going to put them in parentheses. So y equals, and I'm going to do -2x squared minus 8x minus 7, and I'm going to put parentheses around these. And so now to get a 1, instead of dividing like I did on the left side, what I'm going to do is I'm going to factor instead. So y equals, and I'm going to factor out a -2. And if I factor out a -2, I'm left with x squared plus 4x, and my 7 stays the same. Okay, so now what I need to do, again, I'm not touching the y, it's going to stay all alone. I need to I need to complete the square with this, what is inside the parentheses. So I am going to, this all stays the same. Remember, I just need to add one term. So I take the 4, I divide it by 2, I get 2, I square it, I get 4. So I need to add 4 here. Add 4. And the -7 stays the same. Now, we just added 4, it looks like, on the inside of the parentheses. So what I want to do, if I added 4 there, remember, I'm going to want to take away 4. But there's a trick. There's a little trick here, and it has to do with this, okay? So if I were to distribute this -2 through, I would see that I've actually done what? I've actually subtracted 8 from the inside, because this 2 is going to multiply, excuse me, the -2 is going to multiply by the 4 to give me a -8. So if I'm actually subtracting 8, I can't add 4 or subtract 4 here. I actually need to add 8 to counterbalance what I've done inside the parentheses. So essentially I've added by 0, all right? So this is the one little trick with this. And it's easy to make mistakes here, so make sure you go slow. So let's see what happens now. I've got a -2, and then this inside, I'm just completing the square, right, by design. That's why I added that 4. And here, I need to add 1 once I simplify the -7 and the 8. So this looks like it's fewer steps. I mean, it can be simpler, but that one step there where that if you factor anything out, it's very easy to make mistakes. So be careful. If this is the way you choose to do these, be very careful. Again, we can see that our vertex is going to be the same. It's going to be that -2, 1. And our A is -2, so we're going to open downwards, and we're going to be a little skinnier. So there's 2 ways to do a little more complicated problem. Now, in this, compared to the last problem, you'll notice it's the same vertex. So all I've done is I've flipped it upside down and made it skinnier. And it's really important to be able to look at a couple of different parabolas and their vertex equations and be able to compare and contrast them. And let's look at another example and change it a little differently. Okay, for our final example in this video, what I want to do is look at this quadratic. So y equals 1/3 x plus 4/3. Oh, that's an x squared plus 4. Oh my. Let's try this again. So y equals 1/3 x squared plus 4/3 x plus 7/3. And so this one, all right, looks a little different than the ones we've done before. We've got all these nasty fractions floating around. So again, I'm going to show you 2 different ways to do this, and we'll try and get through it and see it. Hopefully we get the same thing. So I've got a 1/3 in all of my terms on the right. So a nice easy move here to get rid of our fractions. Let's just multiply everything by 3. So if I multiply the left side by 3, I'm going to get 3y. Now the right side is going to get a lot nicer for me. So I've got an x squared plus 4x plus 7. Okay, so now if I'm going to complete the square, I want to get just the x stuff on the right using that first way. So 3y minus 7, I'm subtracting 7 from both sides, is x squared plus 4x. Now I need to complete the square, so let's do 3y minus 7 is x squared, and actually I'm going to need to move over a little bit because I'm going to have to add something to that left side in a moment. So let's try this. 3y minus 7 equals x squared plus 4x. Divide by 2. 2, square it, gives me 4. And now, what do I have to do? Since I added 4, I think I'm going to need to add 4 to this side, just to keep everything in balance. So we could simplify a little bit in this next step on the right side. So I think I'm going to get 3y minus 3 here. And on the right, I'm going to get x plus 2 squared. There's my completing the square step. Now, to get it in the right form, I'm going to have to get rid of that 3 next to the y. It looks like I'm pretty close, but that 3 next to the y is goofing things up for me. So let's try dividing everything by 3. What's that going to look like? Well, these 3's are going to cancel, and I'm just going to go to y. The -3 over 3, I think, is going to become a -1. And then I'm just going to put a 1/3 out front instead of leaving it underneath in the denominator here to get that. Well, that looks like the right form. What do we know? We know the vertex here. That's going to be -2, 1. And the a term here is positive 1/3. So we're going to be opening up. And since a is between 0 and 1, we're going to be wider than the previous one. Now, we haven't exactly gone through and strictly talked about how to graph the skinnier and wider. You could always do it with a table, but it's good to keep in mind that since that 1/3 is there, it's going to be a wider parabola than if it was 1, for example. I usually compare them all back to where a is 1 just to get a basis for comparison. So that's good. Notice, again, we've taken the same vertex, -2, 1, but this time we just made a wider parabola and it's facing up. So, just to be consistent, let's quickly go through doing this the other way, with a factoring way. Y equals 1/3 x squared plus 4/3 x plus 7/3. And if we're going to keep everything on the right side and leave the y, what we're going to want to do is factor out a 1/3. And if I factor out a 1/3 from these first two terms, right, remember, these are the only two I want to factor from. I'm going to get a 4x, and I'm going to leave the 7/3 here. So now, continuing on, I don't know why I made one of those a square bracket and one a rounded bracket, but so be it. So now I've got my 1/3, and I'm going to do the x squared plus 4x. Again, divide the middle term by 2, square it, and add it. So I'm going to add 4 here. And the 7/3 is going to stay. But this is that tricky part. So it looks like I just added 4, but because of this 1/3 multiplying by that 4, I've actually added 4/3. So to counteract that, I need to subtract 4/3. So there's that tricky part again. Make sure you go slowly through there. So now, if I simplify and complete the square, I'm going to get 1/3 x plus 2 quantity squared plus 3/3, which is just going to be 1. So I'm going to get the same vertex, -2, 1. And the a is 1/3, again, is positive. So I'm going to open upwards. And it's going to be wider than it would be if the a was just 1. So hopefully these examples helped. And good luck completing the square to get parabolas into vertex form.